So, if you've ever found yourself staring at a weather app, a thermostat, or maybe a baking recipe, completely baffled because the numbers just don't make any sense, well, you are definitely in the right place. We live in this highly connected world, right? But we're still divided by two very different ways of measuring temperature, Celsius and Fahrenheit. In today's explainer, we are going to completely demystify these two scales. We'll look at exactly where they came from, how they actually relate to the real world, and most importantly, how you can easily and accurately translate between them without breaking a sweat.
Okay, let's dive into the agenda. Today we're covering 1. A tale of two scales, 2. Key reference points, 3. The conversion formulas, and 4. Step-by-step conversions. And hey, don't worry about the maths just yet. We are going to ground everything in relatable, everyday examples before we even look at a single equation.
All right, Section 1, A Tale of Two Scales and the Geographic Divide. You know, to really understand temperature, you have to realize that a thermometer is just a tool, but the numbers on it, that depends entirely on where you live. While the vast majority of the globe uses Celsius, the United States remains the primary champion of the Fahrenheit scale.
Now, what's really fascinating here is the foundational mathematical difference between the two systems. Celsius is built on this perfectly clean round number. Water freezes at 0 degrees and boils at 100 degrees. Boom. It's exactly a 100-degree gap. But Fahrenheit, it operates on a completely different logic. Water freezes at 32 degrees and boils at 212 degrees, creating a much larger 180-degree gap between those exact same two physical states of water. When you look at both scales side by side, you can literally see that structural difference playing out. Way up at the very top, 212 degrees Fahrenheit perfectly aligns with 100 degrees Celsius. But as the temperature drops, the numbers start changing at totally different rates because of that 180 versus 100-degree gap. Right down until freezing, where 32 degrees Fahrenheit locks in with exactly 0 degrees Celsius. So you might be wondering, why do we even have two scales to begin with? Well, it really just comes down to a historical quirk. Two brilliant scientists were trying to measure heat at almost the exact same time. Daniel Fahrenheit invented his scale in 1724, and less than 2 decades later, in 1742, Anders Celsius created his. They were competing scientific standards born in the exact same era, and somehow, nearly 300 years later, they've both fiercely survived. Moving right along to Section 2, Key Reference Points, Grounding the Numbers. Before we actually learn how to mathematically convert these scales, the absolute best way to understand them is to anchor them in the feelings of your everyday life. I mean, numbers on a page are just abstract, but a hot summer day, that's something you know in your bones. Let's walk through these vital anchors. Starting at the bottom, we have freezing ice, 0 degrees Celsius or 32 degrees Fahrenheit. Step outside on a brisk, cold winter day, and you're feeling about 10 degrees Celsius, which is 50 Fahrenheit. Head back inside to a comfortable room, and you're sitting at 25 Celsius or 77 Fahrenheit. Your own normal body temperature is 37 Celsius, which is that super familiar 98.6 Fahrenheit. A brutally hot summer day hits 40 Celsius, crossing that 100-degree mark to 104 Fahrenheit. And finally, a rolling boil on your stove is 100 Celsius or 212 Fahrenheit. By mapping these 4 key checkpoints sequentially, freezing in blue, room temp in green, body temp in orange, and boiling in red, you really start to build a visual intuition. If you just lock these into your mind, you'll rarely even need exact math. You'll already have a fantastic feel for what the other scale means. All right, on to Section 3, the conversion formulas. Think of this section as your ultimate decoder ring. A super simple mathematical tool to perfectly bridge the gap between these two worlds. There's a really distinct visual logic going on here. If you're starting with Celsius and you want to find Fahrenheit, you just follow the green path to the right. But if you have Fahrenheit and need Celsius, you follow the orange path back to the left. As you can see, the formulas look just a little bit different depending on which direction you're traveling. So, here is the absolutely crucial point, the order of operations. This is honestly where most people make mistakes, so let's set a mental hook right now. When you're going to Fahrenheit, you multiply by a fraction first, and then you add 32. But when you go the other way, back to Celsius, you do the exact opposite in reverse order. You subtract 32 first, and then you multiply. Okay, Section 4, Step-by-Step Conversions, Math in Action. We've got the rules down, so let's slow the pacing down a bit and put this math into action with 4 real-world examples.
Example number 1. Let's say you're traveling and the forecast says it's going to be a mild 20 degrees Celsius. What is that in Fahrenheit? Step 1, we write out our green formula. Fahrenheit equals Celsius times 9 over 5 plus 32. Step 2, we multiply first. 20 times 9 is 180, and 180 divided by 5 is 36. Step 3, we just add our 32. 36 plus 32 gives us 68 degrees Fahrenheit, a totally beautiful mild day. Let's try another one going in that exact same direction, but this time with a really vital human metric, 37 degrees Celsius. Step 1, we multiply. 37 times 9 is 333. Divided by 5 gives us exactly 66.6. Step 2, add 32. 66.6 plus 32 gives us 98.6 degrees Fahrenheit. And that calculation right there is exactly how we arrive at the familiar normal body temperature. Now let's throw it in reverse and see how this builds. Let's take the Fahrenheit boiling point and prove that it gets us right back to the Celsius boiling point. Step 1, write down our orange formula. Celsius equals Fahrenheit minus 32, all multiplied by 5 over 9. Remember our mental hook from earlier? We subtract first. Step 2, 212 minus 32 is exactly 180. Step 3, we multiply. 180 times 5 is 900, divided by 9 equals exactly 100 degrees Celsius. See, the math works out perfectly. For our final example, let's take a sweltering 95-degree Fahrenheit summer day. Step 1, subtract first. 95 minus 32 leaves us with 63. Step 2, multiply that by our fraction. 63 times 5 is 315, and 315 divided by 9 is 35 degrees Celsius. So a hot 95-degree day in Miami converts nicely into a 35-degree day in Madrid. Now, before we completely wrap up the math, I want to let you in on a fantastic little insider secret directly from our source material. It's a total life hack for anyone who just wants a quick mental shortcut without reaching for a calculator. Here it is. A quick rough check is that every 5 degrees Celsius is about 9 degrees Fahrenheit. So if you know 30 degrees Celsius is hot, jumping up 5 degrees to 35 Celsius means you're jumping up about 9 degrees in Fahrenheit. It's just a great tool to keep in your back pocket to see if your mental math is on the right track. All right, active learning time. It is your turn. We literally just learned the steps, so let's see if you can put them together. How would you convert a brutally hot 104-degree Fahrenheit day back into Celsius? I'll give you a second. Remember your orange formula. First, subtract 32 from 104. Keep that number in your head. Got it? Now multiply that number by 5 and divide by 9.
Do you have it?
The answer is 40 degrees Celsius. If you got that right, massive congratulations. Let's quickly review those mental steps. 104 minus 32 is 72. 72 times 5 is 360. Divided by 9 gets you right to 40. You, my friend, now officially hold the keys to translating temperatures across the globe. We've covered the history, we've walked through those everyday anchors, and we have totally conquered the math. But looking at how these two very different scales have survived for centuries leaves us with a pretty fascinating final question. With our modern world being more globally connected than ever before in human history, will we ever finally put our differences aside and agree on just one single temperature scale? Or are Celsius and Fahrenheit just destined to dance side by side on our thermometers forever? It's definitely something to think about the next time you step outside to check the weather. Keep learning, keep asking questions, and I'll catch you on the next explainer.